Today we get to start with Chapter 2. And throughout Chapter 2 we're going to be working with inequalities. So it is really important that you get off to a good start here in Lesson 2.1, having a good understanding of what an inequality is, how to write one, how to read one, how to graph one, what do they really tell us. So let's look at this table that we have here first of all, where we have the symbols and then the words that can go with, and then what would the graph representation be. So our first one that we have here, where we are, this one we're going to look at. We have the, looks like a V turned on its side, and the V is pointing to the left. That can be represented with the words, and we're going to add the word is in front of this. That's really important. Is less than. So when we read that symbol, we say is less than. And when we're looking at a graph for that, we're saying that when we put an open circle like this right here, we have an open circle, and that means this is where we're going to start, but that one's not included. That's why it's left open. And then what numbers on the number line are less than that, they go this direction. And I typically show the graph by making the number line thicker there and making the arrow at that end also thicker. Okay, let's move on to our next one in our table here. Now notice it's a V lying on its side, still pointing left, but now it has a little dash under, a little bar under it. So we have, let's include the word is here again, very important, is less than or equal to. There's two conditions, and it only has to meet one or the other. So the expression has to be less than the other expression, or it can be equal to it. Let's put a semicolon here. Another word phrase that could represent that we could say for that same symbol is no more than. Is no more than means it can't be that there's a point that it stops at. It can't be any more than that. So it can be that number, then it has to also be something less than that. And we also have, let's put a semicolon there, at most, and let's add the word is here also. Is at most. So again, can't be any larger than that. So the is less than or equal to symbol would replace those words, that word phrase. Okay, and our next one in the table, when we have our V and it is sitting on its side pointing to the right, we are going to say the words is, add that in there, is greater than. Okay. Now, I forgot to talk about the graph in the last one, so we're going to go back up to that one. Notice when it had the equal to part, the or equal to part, the circle where we start at is shaded in because that's the equal to part. And then the is less than is still this shaded part going to the left on the number line because those numbers get smaller and smaller. Well, notice now that we're back to this one where it did not have the equal to bar. It has an open circle. It doesn't shade it in because it's not included. That condition is not part of it this time. Only numbers that are greater than are included. And then what's different about the last one? Well, we have our is greater than symbol, but with a dash or a line underneath it. So that means we have the to condition one, is greater than or equal to. It has to meet one or the other. Some other words we might see used for the is greater than or equal to symbol is no less than. So in other words, it can't be smaller than, so it's got to be greater. Is at least. So it starts somewhere and then it has to go up. Also is at least. And notice this time our endpoint is shaded in because that meets the equal to condition, or it is shaded also going this direction. Those are the numbers that are greater than that endpoint, that starting point, we could call it. Okay, so those are all really important that we make sure we understand those so that now in this next section we're going to match an inequality with its graph. But before we do that, we're actually going to write what does this part tell us? It says is greater than, let's write that on this line, is greater than or equal to, it has that equal to bar, -4. Is greater than or equal to -4. X, meaning what are all the numbers that qualify for this condition? So the numbers that qualify for the condition for X have to be greater than -4. So that would mean they have to be shaded to the right. And then the equal to part means -4 can be included, so -4 would need to be shaded in also. So here's our graph right here that has the numbers that are greater than -4 shaded, and -4 itself is shaded because any of those numbers, -4 or these numbers are greater than -4. So graph D is going to be our graph for that one. In the next one, it says, again, we're going to write this down. What's this tell us? This tells us that X has to be is less than or equal to -4. So again, it can meet one condition or the other. Whatever we decide X is going to be, it has to be less than -4, or it can be equal to -4. Well, that means -4 has to be shaded in, and the numbers less than -4 would be to the left. So I'm thinking here's our graph right here for that one. -4 is included, and so are all the numbers that are less than -4. So we're going to say graph B matches up with that one. Okay, in our next one, it says, whatever you want X to be, better be is greater than -4. That's the condition. Whatever you decide X can be, better be greater than -4. So -4 can't be included. Our circle at -4 can't be shaded in, but the numbers greater than -4 go to the right of it. So I'm thinking here's our graph that shows X being, the shaded region represents X, being greater than -4. So we're going to go with graph A. Well, by process of elimination, it's looking like the last one's going to be C, but let's verify it. So this says X has to be is less than -4. Whatever you put in for X to make this inequality true, it has to be less than -4. So -4 can't be included, but numbers smaller than -4 can be. So sure enough, graph C does represent that. Okay, so it's important that we understand which graph matches the algebraic representation of the inequality. Okay, let's go on to writing the inequality now. They give us the graph, we're going to write the algebraic inequality. So our shaded region, you can use any variable you want, by the way. We'll just stick with X. We're going to say X, the shaded region, is greater than, it's going to the right, so is greater than, 6 is not shaded in, so we're not going to put the equal to bar because it can't be 6. So X is greater than 6 is the algebraic representation of the solution shown on that graph. Okay, let's look at our next one. Again, we're going to start with our variable, and on the other side of the inequality will be the endpoint, or the point that it goes from, starts from. -2 is included, so I know the equal to bar has to be there because it's shaded in. And I need the numbers that is shaded to the left, so those numbers are smaller than -2, so is less than So x is less than or equal to -2, algebraically represents that graph. Okay, once you try those last two on your own, then you can look up here to see if you and I agree. Okay. So here are the algebraic representations for those two graphs. I want to talk about the last one here. I just want to show you that, and maybe some of you have already done this. When you did these two on your own, maybe you wrote it differently than I did. And I want you to know that there is another way to represent it algebraically. So we also have, this is like just saying, here's another way that an algebraic representation of that graph means the same thing. We can start with the point, the value at the end point, the starting point. We can start with that in our algebraic inequality, and then we describe its relationship to the shaded region. So x goes on the other side. So now what we have to do is we have to say, how is 45 related to the shaded region? Well, 45 is included, so we know the equal to bar is there. But according to our graph, the numbers to the right of 45 are shaded, so 45 is actually smaller than all of those numbers. So we would have to say 45 is less than the numbers for in the shaded region. And the equal to bar includes the 45. So notice there are two different ways to represent this. And notice what happened. The x and the 45 traded places, and the symbol switched direction. It went from being is greater than to is less than. So there is another way to represent it. So you might have done something like that. So again, this one over here, if you did do it, 8.5, and x would trade places, and the symbol would go is greater than instead. 8.5 is greater than all of the numbers in the shaded region, and that's true. Okay, let's go to the back side, see what we're going to be doing back there. Okay, so it says graph each inequality. So now we're going to graph them, and I'm going to graph a little bit, I'm going to require your graphs to be a little bit different maybe than they do in the book. What I do is, first of all, we have to get our number line set up. We're not going to graph it yet, we're just going to set it up. So we're going to pick one of the tick marks to represent where -7 is going to be. And then what I want are integer neighbors to the left and to the right. So the integer neighbor to the right of -7 is -6. The integer neighbor to the left of -7 is -8. So we're just kind of getting a snapshot of where do we want to be on the number line. And now we're actually ready to graph it. We're going to put our circle at our end point, our starting point, and we're going to make a decision about is -7 included? Should we shade that circle in or not? Our inequality says x has to be greater than -7. Doesn't say the equal to part. It can't say it can be -7. It has to be greater than -7. So we're not going to shade -7 circle, but we're going to shade all of the number line heading to the right because those are the numbers that are greater than -7. So that's how I want you to do your number lines. Integer neighbors. Okay, let's move on to this one. We have P is greater than or equal to 8. Okay, first thing we're going to do is say, you know what, I need to pick where on the number line I want to be. So 8, integer neighbor to the right, 9, integer neighbor to the left, 7. That's enough labeling, that's all I'm requiring of you. And then we're going to put our circle at 8 and decide if we should include it or not in our shading. Because it says P is greater than or equal to 8, 8 meets the or condition, or equal to condition. And then the numbers to the right of 8 meet the is greater than condition. Okay. Let's take a look at our next one here. That is 2.5, 2 and 5/10 is greater than or equal to r. So first of all, let's just leave it like it is, and let's label our number line. So 2.5, 2.5, and remember, I want integer neighbors. Well, 2.5 is smack dab in the middle between two integers, so we should be able to just put a 3 at this tick mark and a 2 at that tick mark. Okay, and then let's put our circle at 2 and 5/10, 2.5. Let's put our circle there and decide if we should include it or not. Should we include 2.5? Well, it says it has the equal to bar, so yes, we should include it. And this is how our inequality reads right now. It says 2.5 is greater than all of the numbers r can be. 2.5 is greater than all of the numbers r can be. So that would be these guys. 2.5 is greater than all the numbers r can be. Okay, let's do the, writing it the other way, just to see if we have a good graph here. So r and 2 and 5/10, 2.5 trade places. The inequality symbol switches direction when we do that. So this now reads r, the shaded region, is less than or equal to 2.5. 2.5, and we did shade the numbers that are less than 2.5. So we did well. Okay, and then our very last one here, y is less than -1. So let's get our number line set up here. -1. Integer neighbor to the right is 0. Integer neighbor to the left is -2. And our circle goes at -1. Is -1 included? No, no equal to bar. So we can only shade numbers for y that are less than -1. Y can only be these numbers less than -1. Okay, so being able to graph them correctly is an important part of our inequalities also. Okay, and last but not least, we're going to do some writing our own inequalities for a situation and graphing them. Just like we always do with our word problems, we pick a variable to represent the unknown, we describe what it's representing, and then we'll write the inequality and graph it. So we have, to enter the play area, children must be more than 4 feet tall. So what would all the numbers that we're going to end up in our solution region, in our graph, going to represent? Well, let's use h, because h, what is unknown this time is height of the child. So for the child, it's important that we know their height to know whether they can get into the play area or not. So h is height of child. So in our inequality where we use h, we're going to represent what children can get into that play area. Well, their height has to be more than 4 feet tall. So is greater than, and it says more than 4. It doesn't say 4 feet or more. It says more than 4. So we're not going to include the equal to bar. And so we say the inequality that represents that is h is greater than 4. Okay, well they have a number line labeled here for us, so we can go right to graphing it. We're going to put our circle at 4 and decide if it can be shaded in or not. It cannot be, so we're going to leave it open. And the numbers that are greater than 4 go to the right on the number line. Okay, and we know that even though this goes on forever and ever, in reality, at some point, even probably pretty unlikely that a child's even going to be 6 or 7 foot tall, but we're just showing that anything more than 4 feet tall is going to get them into the play area. Okay, as of July 1988, the speed limit on rural interstates in Virginia is 65 miles per hour. We need to represent that on our graph in an algebraic inequality. So what's really going on here? The speed limit is 65 miles per hour. So really what we're going to represent is how fast can you be driving? What's the speed that you can be driving? So let's use, I don't like S because it looks like a 5, so let's just use X. So X is the speed driven, or the speed, no, they don't put it like this, the speed allowed. Because that's what speed limit is. They're giving you an allowance. They're saying, you can drive this. If you go beyond it, you're going to get a ticket. So X is the speed allowed. Well, X, the speed allowed, if the speed limit is 65 miles per hour, that means you can drive 65 miles per hour, but you might not want to risk 66 because that's going to get you a ticket, possibly. Sometimes you get away with it. You don't have to drive 65, though. You can drive 63 if you want. So X is less than or equal to 65. So in other words, don't go over 65, but you can go 65 because that's the limit. So now we're going to go to 65 on the number line, and we're going to put a circle that is closed in, that's shaded in, because we can go 65, and then we can go speeds under 65. Okay, and again, we know that even though this goes on forever and ever in that direction to the left, eventually we'll get into negative territory, and we don't really drive negative speeds. But we'll talk about those restrictions a little bit more when we start solving inequalities. For now, we just show it, the inequality represented graphically. Okay? And then our last one. Josephine sleeps less than 8 hours each night. So we need to represent Josephine's sleep, right? So again, I don't really like that sleep starts with an S, so we don't want to use S. So let's use Y this time. Y is, so Josephine sleeps. So that would be, Y is representing the number of hours sleeping. Okay, number of hours sleeping is really what we're going to represent here. So Josephine's number of hours sleeping, Y. She sleeps less than 8 hours, so she doesn't even sleep 8 hours, so we can't include 8. 8 is our starting point, but she sleeps less than, so our inequality has to be Y is less than 8. Okay, this time the number line is started for us but not labeled yet. So we'll put an 8 under one of the tick marks. Put integer neighbors to the right and to the left. And then we'll show what are the number of hours Josephine sleeps by graphing now. So less than 8, can't have 8, don't want to shade that in. And we were going to shade all of the numbers headed to the left of that show is less than 8. And again, this one really would have a restriction because it would eventually get into negative territory and we don't have negative hours of sleep. But for now, we'll just leave it like this until we get into solving. Okay, that's it for today. It's really important, though, that you make sure you are good with this so that when we do start solving them, this is not what's going to be the issue. Okay, good luck.